Hello, I'm Rupeng An. In this module, I would like to introduce the Lord of retrievers, or called merge retrievers. Many of us are familiar with the RAG, or retriever augmented generation, which is extremely useful when we want to reduce large language model hallucination problems and try to make the model grounded to the data set that we provide. The traditional RAG system has the problem of so-called lost in the middle when we try to retrieve a large number of data points from our database. And when the context is long, often the retriever may not work properly, and the retrieved data may not be specific to the request. To avoid this problem, the loadable retrievers or the merge retriever try to use a separate retrieving process by doing different embeddings on the same data set, and then using the merge retriever to retrieve from multiple retrievers and then combine the results, reducing duplicates, reorder the retrieved document, and then augment the final results using large language model. So today in this session, we are going to go through the process of building a Lord of retrievers or merged retriever, and we can explain as we go through this building exercise. So first, because we are going to use large language models from both OpenAI as well as Hugging Face, you do need to have a OpenAI API key in order to use the OpenAI large language model as well as its embeddings. And you should save your OpenAI API key to your environment .env file. And then we're also going to use a number of methods from the langchain, including the langchain Hugging Face, the langchain core, as well as langchain OpenAI and langchain community. We'll be also using a local vector database, Chroma. So you need to import Chroma into your text editor. And to use OpenAI API key, you can load the environmental variable using load.env and then set the system environment as OpenAI API key. Here, we are going to load a PDF file. So this is a file of a book that I published a year ago called Supercharge Your Research Productivity with ChatGPT, a practical guide. It's a very extensive book, over 300 pages, showing how using real-world examples, showing how you can use ChatGPT to perform all 10 stages of research. So we are going to use that book as a demonstration. And we use the PyPDF loader to load the PDF file, this entire book. And then I use the load and split function to load the book, read the book in text file, and also split the book into many chunks. So each chunk has a small number of tokens that can be accessed can be stored in the vector database. Okay, and then I'm going to create 3 different embeddings, 2 embeddings from Hugging Face using 2 different models from Hugging Face. One is all media LM L6 version 2, and another is multi core media LM L6 dot version 1. So I intentionally choose 2 different embeddings because that is going to be helpful in building a stronger set of retrievers that are sufficiently different in retrieving documentation. And I also create the 3rd embedding using the OpenAI embeddings. And after that, I'm going to initiate Chroma vector database. It's going to be a local database saved in the local folder. And I'm going to initiate the first vector database using the first Hugging Face embedding, Hugging Face embedding 1. So here I use the from documents method, and I provide the chunked documents from the loaded PDF file. I provide the Hugging Face embedding 1. And then I also set persistent directory to be a local directory under the DB. And by the same token, I initiate the second Chroma vector database using the second Hugging Face embedding. The syntax is exactly the same, except here I use Hugging Face embedding 2. After that, I can build, based upon the 2 vector databases, we can define 2 different retrievers using unique embeddings and search types. So based upon the first vector database, I'm going to build the first retriever, and I'm going to use the similarity as the search method. Basically, the similarity algorithm is going to be used to match the inquiry that you are going to provide later. And each of the chunked document that has been vectorized. And I'm going to pull the top 5 documents that are most similar to the inquiry, based on the similarity search algorithm. By the same token, I'm going to create the second retriever based on the second vector database, and I'm going to use a different search type called MMR. Again, I'm going to use that. I'm going to identify the top 5 documents that has the highest score for MMR based on its similarity to the inquiry. Since I have created 2 retrievers, and now I'm going to use the Lord of Retrievers, the LOTR, or sometimes called merged retriever, to merge the output from both retrievers. And I'm going to call the merger retriever method, and I'm going to provide retriever 1 and retriever 2 in the list to the argument of retrievers. After you have defined the Lord of Retrievers, now you have 2 options. So option 1, think about, because you have documents retrieved from both retrievers, and some of documents could be the same, some could be different, right? And the option 1 is to help you remove the redundant documents from the merged retrievers. Right? And option 2 is to pick a representative sample of documents from the merge retrievers. Okay? So you choose either option 1 or option 2, and both would achieve similar results. That is to remove the redundants and then choose a small sample of documents from both retrievers that fit the best to the inquiry. So let's first take a look of option 1, which is to remove redundant results from merged retrievers. We can remove the redundant results from both retrievers using another embedding. So here we set the filter to be embedding redundant filter or retriever, and we are going to use OpenAI embeddings for that purpose. Okay. And then the second step is quite interesting because no matter the architecture of your model, there is a substantial performance degradation when you include manually retrieved documents, say 10 or more retrieved documents. So this is so-called the middle, lost in the middle problem. And one way to deal with that is to reorder documents after removing redundancies. Okay? So to reorder the documents, we can use the long context reorder, and we can build a document compressor pipeline that includes both the filter that you defined using the OpenAI embedding, and then using the long context recorder to reorder. Okay. So after that, you can define the overall compression retriever, which does two things. One is to remove the redundancy, and the second is to reorder the retrieved documents. That retriever is called contextual compression retriever, that you provide your pipeline, and you also provide the base retriever, which is your lord of retrievers. Okay. So that is option 1. But you also have option 2, which is to pick a representative sample of documents from merged retrievers. So in that exercise, you, instead of using the embedding redundant filter, you use the embedding clustering filter, which you are going to create clusters, based on the retrieved documents. And then for each cluster, you are going to choose the top, the most relevant document from that. Okay. You can also decide to sort the documents based on the retriever scores, etc. Okay. So to create that embedding clustering filter, you provide the OpenAI embeddings. You decide upon how many clusters you are going to create and how many documents from each cluster you are going to retrieve. And also you can set sorted equals true, which is going to sort based on the auto retriever scores. Okay. And after that, you still want to reorder the contents to avoid lost in the middle problem. And after that, the procedures are exactly the same as option 1, that you create your document compressor pipeline, which include both the embedding cluster retriever as well as your reordering using long context reorder, and then you can build your contextual compression retriever. Okay. So you can try option 1 or option 2, depending on your task, and see which one perform better. But since you have built your compression retriever, now you just need to do the very last step, which is augmentation, right? So the augmentation basically is the way that you rewrite uh, the retrieved document from the compression retriever using large language model and feed that to the user. Okay. So I'm going to use the OpenAI GPT-4 model. uh, I initiate that large language model, and then I can start building this Q&A chain. I'm going to use the retrieval QA chain. I provide the large language model, and I'm going to set the chain type to be staff. So staff is really good for question answering purposes. And then I just provide a retriever, and retriever is just a compression retriever that I created. And after that, we can run the QA. So here I make a query. What are the 10 principles for prompt engineering? So there's actually in the book, this ChatGPT book, I wrote extensively about the principles for prompt engineering in the first chapters, and they span over a number of pages. So I tried using the naive RAG, and it could only retrieve 4 to 5 out of the 10 principles because they span over many pages. And then let's take a look of how the Lord of Retrievers may perform to retrieve those 10 principles. Okay. So I use QA chain invoke as the way to invoke the Q&A chain, and I'm going to print the response to my terminal. Okay. So that's first comment out the option 2 so that we can only take a look of the results from option 1, which is to remove redundant results from merge retrievers. Okay. So I'm going to run this. We are It's going to take a while. It's going to give you some warning, but they are fine. Just basically showing that using the Hugging Face model, since we have already downloaded the model, we won't have to download that again. And these are the results here. So the query is, what are the 10 principles for prompt engineering? The results, the 10 essential rules of prompt engineering are as follows. Number 1, be specific and clear in your prompt. Number 2, break down complex questions into simpler parts. 3, experiment with different prompt formulations. 4, set context. 5, ask for step-by-step explanation. 6, request sources and citations. Number 7, explore alternative viewpoints. Number 8, apply constraint to control response length and format. Number 9, provide examples to guide the model. Number 10, foster critical thinking and exploration. So the Lord retrievers definitely perform better compared to the naive RAG, and correctly extracted all 10 principles for prompt engineering from that book. Okay, so this is well done. And let's take a look of the second option. Pick a representative sample of documents from the merged retrievers. So let me and command hit this and command out option 1. Okay, so I'm going to rerun this. Let's see whether the option 2 can also give us all 10 principles back correctly. Okay, so here we go. The 10 essential rules of prompt engineering as follows. Well, all the way to 10, it seems that the option 2 can also correctly identify and extract all 10 prompt engineering principles. Okay, so that's all we want to talk about today. Please subscribe to my YouTube channel so that you can follow us along the journey in artificial intelligence. And also in the show notes, I'll make sure to put today's uh, tutorial, the Python code to my GitHub repo. So feel free to download and use them as needed. Thank you. Bye.